Alright, so I asked you guys to do all this stuff, and this problem, really what we focused on yesterday was just basically finding the domain algebraically. With the square root, you have to basically put something greater than or equal to 0. Put your finger on the part that's greater than or equal to 0. You should be setting the radicand greater than or equal to 0. Thanks. 5x minus 12 greater than or equal to 0. Now the reason why it is equals to is because you could take square root of 0, which is just 0. How do you solve that? So I have 5x greater than or equal to 12. Divide by 5 on both sides. X is greater than or equal to 12. 12 fifths. Now, do we flip the inequality sign? You only flip it when? Raise your hand if you got that so far. Okay. That's what we learned yesterday. This is an inequality. If I do the x-intercepts, you have to make y equal to 0. You guys just had about 8 minutes to do the problem, so I'm going a little bit faster. 0 is equal to the square root of 5x minus 12. That's how you get rid of the square root. Both sides, we're going to take the power of 2. So now I'm left with 0 equals 5x minus 12. Add 12 to both sides, you get 12 equals 5x. And divide by 5 on both sides, x is equal to 12 fifths. So my order pair there would be 12 fifths, 0. And that should make sense to us, because if you actually think about it, that was actually the same number we got down here. Does that make sense? That's the starting point of where the graph is going. Let's use green. Y-intercept you have to make x equal to 0. So I have d of 0, which is just function notation, which we learned that you're just basically putting your x value to be 0. 5 times 0 is 0 minus 12. Square root of negative 12 is? It is I, so the square root of negative 1 is I, and the square root of 12 would be 4 times 3, and the square root of 4 is 2, so you get 2I radical 3. Now, the big idea for that one, is it real or complex? Which means there is no real solution here, which basically means there is no y-intercept. Raise your hand if you got that. Now, I know some of you probably went to your graphing calculator pretty quickly. I want you to start thinking about this. Okay, what would it look like if it didn't have a y-intercept? That means really it's probably going to be in which quadrant? 1. Do you see how we're kind of using our math puzzle pieces to think about this? Now, 12 fifths is really where? 2 point what? Someone put it in their calculators? You guys doing 2.3? What? 2.4. So between 2 and 3, closer to 2. There it is. Closed circle means it's enclosed. If you want to find some nice values, I can just go to second graph. I'm going to be looking for some nice whole numbers. I know we have it in there. Second, 5x minus 12. Let's try that again. Calculator verifies when it says error, because in that direction there's nothing, right? Anything nice? I'm gonna guess, oh, that's too high, but we'll just do something like, I don't know, maybe like 7. 7, 3, 6, 7, and then like underneath 5. $4.79. Does that make sense? And then we'll just take my colored pencil, and my graph looks like this. Raise your hand for a graph kind of look like that. Okay, and then from here I have a visual now, and I can just find my domain. We already found the domain algebraically. I already know in inequalities that my answer is, this one's super fancy. All your values of x are all real numbers except for only when x is greater than or equal to 12/5. Now, this is what you're used to, right? So this is super fancy, like you really get it. This is like you're just surviving, right? In domain going left to right, x is greater than or equal to 12/5. On the x-axis, going towards the right where numbers are greater, this is where only you can get answers for x, or where you can pick from. Let's do interval notation. From the left side of the graph, this is the first thing I touch. Parentheses or bracket. Where is this, class? (12/5). And then I go left to right for domain. Last thing I touch is the arrow, which is? Remember, positive infinity, you don't have to write anything. For the range, which direction? So the first thing I'm touching is 12/5? Remember, what are we talking about? Domain or range? Range is which axis? Okay, so this is what you have to do in your head. You're trying to eliminate this axis in your head. You're focusing on just the y number line. Does that make sense? So on the y number line, what does the graph touch? 0. Y, we can pick all these values that are real, but you're only focusing on a y value at 0. And what's happening? Is it greater than or less than? Greater than or equals to, or greater than? Closed circle, class. Equals to. So you can pick 0. You can get it, because right, if you put in a bunch of numbers, right, you can get a 0 over here. That's what it's saying. So that's why it's equal to. Remember on this part right here, I'm just going to quickly, this would be acceptable for me for now. In purple. And then if we did interval notation on the y-axis, this is at what? 0, including 0 to where? What's the last thing I'm touching? The arrow. It's positive infinity because it's going up. So if it helps you, you can always write your infinities on here. I don't know if that helps. And then parentheses. So the whole goal was just really for you to find the domain algebraically, but you're seeing how all the puzzle pieces are fitting together. Be what greater than or equals 0? The radicand. What is that called? 3 minus 2x greater than or equal to 0. Okay, what do you do? Negative 2x greater than or equal to negative 3. Now what? Divided by negative 2x. Flip the inequality. X is less than 3/2. Raise your hand if you got that. Okay, let's make a graph. It'll totally make sense when you make a graph. Okay, don't waste your time making a bunch of those tick marks. The only thing you really need in the middle is 3/2. If you want a reference, you can put 0 somewhere, but I think hopefully you know where it is. I hope. Okay, question, open or close? When it says equals to, it is a closed circle because of that. Does that make sense? Okay, where are numbers smaller than 3/2? Left or right? That's what your number line looks like for the inequality. Okay, let's now write that as a interval notation. Now, we're focusing on which one, domain or range? That makes sense because the domain refers to which axis? The x-axis is horizontal. Are you seeing the puzzle pieces come together? Okay. Domain goes in which direction? Left. What's on the left side there? Okay. An arrow to a closed circle in interval notation is a bracket. So this is what the graph would look like in interval notation. And then from the left side, you guys said an arrow from the left side means negative infinity. Do you see that? Left side of the graph, left side of the interval notation. Parentheses or bracket? This is not an order pair. It's telling you start here on the left side of negative infinity and stop where? 3/2. Parentheses or bracket? So that would be our answer in interval notation.